Okay, we're going to go through this chapter 5 practice test. It is so important that you actually can do these problems on your own, that you know exactly when you see a problem, you know exactly what you're going to do on the test. So it's going to take some practice. I'm going to show you exactly how to do these problems, and then please redo them. Make sure you know when you take your test, you can go through, you're going to expect to see some very similar problems. So when you see number one, I could type it in exactly how I see it on paper, or I can take 1,000, and this is how I'm going to show it. I'm taking 1,000 and I'm going to raise it to the 3 horsepower. The 3 is your power, the 4 is your root. 3 goes on top of a 4, and I get 177.8, and I'm going to round to 3. Okay. So again, you could, I think it takes more steps to type in exactly, but I'll show that as well. So if I went the fourth root, I can hit a 4 math key and I do option 5. So there's my fourth root. I'm going to put 1,000 underneath my root. I'm going to push away. I'm going to close the parentheses and I'm going to raise it to the third power. I get the same answer. But if you know how to convert, if you know this is really 1,000 3/4. Okay. The next one is not going to give a negative answer. It's going to be the reciprocal. So I'm going to take 125 raised to the negative 1/6. Okay. So it's about 0.45. Okay. You just type in exactly how you see it. Okay. So that should be very easy to complete. Now, this next part, now on your quiz, I just had square root. So now on the test, I'm going to have a different root. Okay, so it's going to be just as easy because I'm going to make sure the exponents work out nice and neatly for you. But I am going to take the number, which is negative 243, and I'm going to take the fifth root, which really means I'm raising it to the 1/5 power. Okay, so technically that should be in parentheses, but it's going to be a negative 3. Okay, negative 3 times negative 3 times negative 3 times negative 3 times negative 3 is negative 243. Now, as far as your exponents, I need you to realize this is what's really happening. I am taking the exponents and I'm raising it to the 1/5. Okay, so you're allowed to multiply your exponents. Since I am multiplying by 1/5, you can divide by 5. That's what it really means. So 5 goes into 15 3 times. So I have x cubed. And then 5 goes into 40 8 times. And there's your answer. And I promise you, if you multiply this out, it's self times itself times itself times itself times itself. 5 in a row, you get back to what you started with. Okay, that's how we do those. Okay, this next one, you can simplify first. We saw one of these. So really, it means this. Since everything's the cube root, it really means this. And I can clean that up. I can reduce. I can make this 2 a 1, make this 6 a 3. Okay? And then I have the cube root of 1 over 27, which is 1/3. Okay? 1/3 times 1/3 times 1/3 is 1 over 27. Okay? Now, this is a new part. This is section 5.5, which should be very easy. Okay, I'm giving you two functions. So I gave you a quadratic and I gave you a linear function for g of x. So the first thing I'm asking you to do is just multiply these together. So I want you to find the product of f times g. You proved to me that you understand FOIL. Okay, I need you to understand negative 4x cubed minus x squared, that's my outers. Here I'm going to get a positive 4x, and I'm going to get a plus 1. There's my expression, okay? Once we find that, I'm going to give you a value to replace the x with, and just do this on a calculator. So wherever I have an x, I'm going to put a negative 8, okay? So it's negative 4, oh, can't see that, negative 4, and then times negative 8, and I'm going to cube it. Then I'm going to have minus parentheses. Make sure you use parentheses, negative 8 squared. Then I'm going to have plus 4 times negative 8. And then I'm going to have a plus 1. And I hit enter, and I get 1,953. Okay? Not hard, so don't be confused by that. The next one, I'm asking you to add these. And you say, Mr. Eggman, how am I going to add these? You add the numbers. They're the same. They're both x to the 1/4. So I have 10 of these, x to the 1/4, and I'm taking away 3 of them of the same thing. That's nothing more than 7 of them. So I could write them this way. So this is an acceptable way of saying the answer, or the 4th root of x. Okay, but you have 7 of them. And if I have 7 of those, I'm simply going to replace. So it doesn't matter how you type this in. I'll use this. It's a little bit easier to do x to the 1/4, but my x is a 16, and I'm going to raise to the 1/4, and I get a 14, and I'm done. Okay, so I have a subtraction problem next. I'm telling you to take these 2 linear rules, and I'm just warning you about subtraction. That's why I have 2 of these then. When you subtract, you're really adding the opposites. So please show this. There is f, my f function, okay? I don't change anything, but I'm going to subtract the entire g function. So minus the quantity, 2t plus 5. And then I'm going to get rid of my parentheses. To get rid of my parentheses, I change what's inside to its opposite. Okay, so I'm just going to rewrite this first part. And then it's nothing more than combining like terms. So negative 4t and a negative 2t is negative 6t, and we get minus 3. Okay, and then I ask you for this part, replace the t with an 8. Negative 6 times 8, and then minus 3, I get negative 51. Okay, so that's basically what you're doing on that Big Ideas 5.5 assignment. So here's another example of a subtraction problem. I take the h function. Okay, don't change anything there, but I must subtract this entire rule, this cubic rule. So I'm going to subtract an x cubed minus 3 minus 2x. So what happens is I change everything to its opposite. So this positive now is a negative x cubed. The minus 3 becomes a plus 3. And the negative 2x is a plus 2x. Okay, so then this part, don't change. And so I like putting my largest exponent first. So I only have a negative x cubed. Then I look for my x's, and I'm going to have 5 of them. And then finally, my numbers, this and this, will be combined to give you a 1. So there's my answer. And I tell you to plug in. So hopefully you can see this. I have negative parentheses, and I'm plugging in a negative 3, and I'm going to cube it. So it's negative 3 cubed, push away, plus 5 negative 3, so 5 times negative 3 plus 1. And you get a 13. Okay? So that first page we got done in under 10 minutes. Okay? This next page, I have a slight word problem that actually you saw in Big Ideas. It's an elephant question, but this time I'm telling you the age. So when you get to a problem like this is so easy because there's nothing to solve. I am asking for the height. I'm asking for h. So I don't know what h is, but I do know that it's 62.5 times whatever age. That age is 20 years. So I put a 20 in for t, because t, I tell you that t is the age in years. Okay, that t represents the age of the elephant in years. That t is now a 20. And I'm simply going to ask the calculator to calculate that. Okay, so This is a simple matter of typing in exactly what we see. Okay, so I have 62.5 times the 20 raised to the 1/3, and then I'm going to add a 75.8. I hit enter, and I can see the height is about, and I'll round to 20 or 245.45, and I believe it's centimeters. Yes. That's all I'm looking for. So it's not about inverse operation. It's about substituting in a number and then evaluating. Okay. Number 10, this was on our quiz. I'll go through the steps again. I am telling you the volume's only 65. So we're not going to expect a really large radius when it's only a 65 cubic feet, but doesn't matter what the number is. I can be any number I can think of. You put it in your calculator, and we're going to divide by 4/3. I'm going to get rid of the 4/3. Once I get rid of 4/3, I'm going to get rid of the pi. So divide by pi. And then the last thing I need to get rid of is to undo cubing, which is the cube root, which is the 1/3 power. So I raise to the 1/3 power, and I get about 2.49. So 2.49 feet is my radius. R equals. Okay, so again, divide by 4/3, divide by pi, raise to the 1/3. Okay, that's how we do it. Now, this next problem is something we just learned in 5-6. I want you to be able to graph a function and then do the steps to find its inverse and then graph the inverse. Okay, so for this, very easy to graph. If you need a calculator, you could graph it. I know this line starts at -4, and its slope is up 2 over 1, 2, 3. Okay, so I'm going to just do a couple dots. So again, if you type this in the calculator, your calculator will give you points, but I think it's easy to graph a linear situation. Okay, so now I could just reverse the roles of x and y, and we could graph the function just like that, but I'm going to find the rule first. So we learned, I'm going to start just by writing y equals 2x minus 4, and the steps to find the inverse. Step 1, reverse the x and y, and then solve for y. So if it's minus, we're going to add. So I'm going to add a 4. And then to get rid of 2/3, yes, you can divide by 2/3, but dividing by 2/3 is really multiplying by its reciprocal. Okay, so I want you to see, oops, this is a 2. So 3 is up top, 2's in the bottom, 3 is up top, 2's in the bottom, and then we're going to clean this up. So my slope of my inverse is up 3 over 2. Okay, just the opposite of up 2 over 3. And then when you multiply, if you need a calculator, you're going to see that this is a 6. So its inverse is 3/2 x plus 6. So we have this dot, which should make sense. This is 6, 0. Well, my inverse has the point 0, 6. Okay. My slope, I don't have quite enough room to go up 3 and over 2. So I'm going to go down 3. 1, 2, 3, and over 2. Okay, down 1, 2, 3, over 2. That's enough to see the inverse. Okay, and just look at this point. This point is 0, -4. Well, on my inverse line, I have -4, 0. You switch the roles of x and y, and that's how it's always going to be. And remember, it's a mirror image about y equals x. So if I could fold my paper over this line, all the dots are going to match up. That's how inverse functions work. Okay. This next problem, we are doing composite functions. We are going to do a function within a function. So with this, it's again easy if you accept that for f of g of x, I'm going to go to my f function, which is 4 times something plus 4. Well, the something, in this case, I'm going to just simply replace the original x, f of x, I'm going to replace it with 1/2 x minus 2. Okay, and I'm just going to clean it up. I'm going to distribute. 4 times 1/2 is 2x minus 8 plus 4. We get a 2x minus 4. That's what the inverse, the composite function comes down to. And the fact is that it's not an x. Okay, we learned that if when you do a composite function, you simplify and you're left with just an x, then it's going to be an inverse function. And so I can answer this question right away because I did not get just an x. Okay, so let's just check the g of x. So g of x is 1/2 times something minus 2. Well, that something is going to be this rule. Okay, and again, I clean it up. I just calculate, I just clean up by getting rid of parentheses, combining like terms. So I take half of this, I get 2x. I take half of 4, I get a 2. And then minus 2, that simplifies to a 2x. Okay, and again, these are not inverse functions of each other. Okay, the fact that both of these would have to be equal to an x for it to be an inverse function of each other. Okay, so that's just a composite function. And we're at the 16-minute mark. Here, I'm going to simply ask you to graph a cube root function. Okay, use a calculator. Okay, now I'm hoping that we know this is actually going to be a shift to the left 2 and down 4. I know I'm going to see that dot on my calculator before I pick up my calculator, but I'm going to pick up my calculator and I'm going to hit the math key, option 4, and I'm going to type in x plus 2. And I'm going to push over and I'm going to have minus 4 on the outside. That minus 4 has to be on the outside. I can see what the graph looks like. Okay, it's going to change right here. And I'm going to go to my table and I'm going to find the point -2, -4. So I know this dot right here right away is -2. When x is -2, we get -4. I'm also going to plot when x is -3. I'm going to be down here at -5. Let's do -1, down 3. And I'll find another nice dot. Let's go right here, -10. I don't have quite enough room, but if I would have room, I'm going to be down here at -6. So it goes like this. And let's see if I can find a positive dot that's nice right here. We can do -2. I have that. And we can do 6, -2. So I'm going to plot 6, down 2, and I'll just connect my dots. So that's the graph. Again, you can tell the transformation right away just by looking at it. Compare it to the cube root of x, left and down. Okay. All you need to do for domain and range is say it's all reals. Okay. There's no just clear starting point. It goes on in both directions. Okay. So now I have number 16, which was already on your quiz. Okay. A lot of people had it correct on the quiz. If you didn't have it correct in the quiz, just learn whatever's in the bottom, I change the sign and I multiply the top and bottom by its conjugate. So that's what it means by a conjugate. Look at what's in the denominator, I change the sign. And when you do that, yeah, you're going to have a messy numerator. 4 times 4 is 16, and you're going to have 4 times root 5, so it'll be minus 4 root 5. Okay, please make sure you realize you cannot get root 20 from that. It's -4 root 5. On the bottom, I better get a number. So I'm going to get 4 times 4, which is 16. The outers and inners disappear, and I'm going to be left with minus root 25, which is a 5. And all I need is an 11. Okay, so that takes care of the conjugate question. And then all we need to do, this is all 5-4 section, we are going to solve equations, okay, by inverse operations. So when I look at 17, I need this x all by itself. So I don't like the -8, so I'm going to subtract 8. So we'll take our calculator, -6, 242 minus 8. and we get negative 6,250. And I'm going to divide by negative 2. And I get 3,125. And it's being raised, x is being raised to the 5/3. Okay, so all we did was get rid of the 8, divide by negative 2. Okay, the last move to figure out what x is, I take the exponent and I flip it. So in this case, I raise to the 3/5 power. Okay, 3,125 raised to the 3 divided by 5, and we get a nice answer. It's always nice when we get a nice answer, but if it's a decimal, just round it. But that is my solution. I can check it. I can plug it back in, and I can calculate, and I would get a balanced equation. This next one, we actually did this a while ago. We did square root functions, but the key to this, I can't undo anything underneath the radical, so I must square. And I don't know how else to say this. You better square a binomial correctly. So the radical drops, and I'm left with x squared minus 10x plus 25. And you say, how can I do that so quickly? I've been doing this for a long time. I know x times x is x squared. This and this agree with negative 10x, and a negative times a negative is always a positive, and 5 times 5 is 25. So now I promise you this will be very easy to factor. Okay, it's not going to take long. So just to show where I got that, I subtracted the 4x and I added a 15. And when you do that, you're left with that trinomial. Okay, and all you need to do is factor, which should not take long, because I'm thinking of ways again. 40 times 1, 2 times 20, 3 doesn't fit in, but 4 times 10 does work, and it also agrees with the negative 14. So 4 is an answer and 10 is an answer. Now, I will not take any points off for not understanding an extraneous solution, but I promise you that 4 does not actually check. So if I replace the x with a 4, I have a negative number on this side. This would be a positive when I calculate. Square root of 1 is 1. If I wanted it to be negative, the person writing this equation would need a negative sign out front, and there isn't one. So only 10 works out. Okay, last two problems. You've seen this in Big Ideas, see it in our notes. We see it on that one bonus paper worksheet that I gave you. You will see this on your exam. Okay, I don't know how else to tell you. You're going to undo 1/4 by raising to the 4th power right away. We have to. So raising this to the 4th power and this to the 4th power, we get rid of the parentheses. Okay, now on your notes, we had the 4th root, which got rid of the radical when we raised it to the 4th. And we need 0. And I promise you, though, this is going to be easy to factor. Okay, I guess it may take a little bit of time to find the pieces, but we should be able to find the solution. So it's x squared minus minus. So lots of ways of getting 48. Okay, 48 times, or excuse me, 2 times 24. I can't get a negative 19 out of that. Okay, so I tried to divide by 2, doesn't work. When I divide by 3, though, I'm going to see 3 times 16. And that happens to agree. That is my answer. And when you do this, you add a 3 and you take the square root of 3. Okay? Over here, you're going to get plus or minus 4. Now, technically, again, I'm not going to get too detailed with this, but really only the positives are going to work. Okay, but I'm okay with plus or minus root 3, plus or minus 4. Okay, but that's what I want to see. I want to see these factors. I want you to understand that you need 0. You're going to Solve the the quartic equation by factoring. And I promise you, the numbers are going to work out very nicely, just like the ones that we've seen. Okay, the last problem. And then I think we have enough practice problems. And if you need more practice problems, just ask, because you have plenty of time to perfect these equations. I am going to have to raise to the 2/3 right away. I can't make any other moves. I can't add a 13, can't do anything to this problem until I get rid of that power. So I'm just simply going to ask the calculator to tell me what 216 raised to the 2/3 is. Okay, so right there it is. 216 raised to 2/3. It tells me 36. The parentheses disappear, and I have one move. Again, that problem should not take long at all to know that it's going to be a 49. Okay, 36 plus 13, that's where the 49 is coming from. Okay, so I am hoping you're going to sit down, you're going to use your notes, you're going to go back and look at some of the big idea problems that I assigned. You're going to go back and look at the different problems that we've done, even warm ups, and you need to make this stuff make sense. And once it starts to click, I need you to remember that it's not going to be anything that's too difficult for you to hopefully understand. So practice, see me, stay after school, ask questions in class, and we should end up getting a good grade on this Chapter 5 exam. Okay, so thank you very much for watching. That took 26 minutes of me babbling on to complete that practice test. So again, you need to practice so you're efficient with these problems. Thank you for watching.